Hello students, this lesson we will revise circular measure. The first content standard for this lesson is Radian. In this standard, you will learn to relate angle measurement in unit radian and in unit degree. First, we will learn the definitions of radian. 1 radian is the measure of an angle subtended at the center of a circle by an arc whose length is the same as the radius of the circle. This means that when the angle subtended is 1 radian, the arc length and the length of the radius are same. For 1 radian, if the arc length is 1 and then the radius is also 1. Similarly, if the arc length is 2, the radius is also 2, and so on. And next, let us learn to convert angle in unit degree to radian. When given an angle in degree, we can convert it to radian by simply multiply it with pi over 180 degree. For example, to convert the angle 135 degree to radian, we can multiply 135 degree by pi over 180 degree. This will give us 0.75 pi radian, or substituting pi as 3.142, we will get 2.3562 radian. Conversely, to convert the angle from radian to degree, we multiply the angle in radian with 180 degree over pi. For example, 2.7 radian, we can convert to degree by multiplying 180 degree over pi. Thus, this gives us the answer 154.7 degree. Let us move on to the second content standard, that is length of arc of circle. This content standard has two parts. In this first part, we will learn to determine arc length, the radius, and the angle subtended of the center of a circle. Okay, based on the definitions of 1 radian that we learned previously, the arc length of a circle, here AB, represented by S, can be found by using the formula S equal to R theta, where S is the arc length and R is the radius, OA, and the theta is the subtended angle in radian. Okay, let us try example 1. An arc AB of a circle of radius 5 cm subtends an angle of 1.5 radians at the center. Find the length of arc AB. Okay, first let's draw out the diagram to visualize this question like this. As seen on the diagram, The angle is 1.5 radian and the radius is 5 centimeter. Using the formula S equal to R theta, we substitute R by 5 centimeter and the theta as 1.5 radian. Okay. Multiplying both these values, 5 times 1.5 will give us the arc length is 7.5 centimeter. Let us try one more example. Example 2. The length of the minor arc is 16 centimeter and the angle of the major sector AOB is 290 degree. Using pi is equal to 3.142, find A, the value of theta in radian, B, the length in cm of the radius of the circle. To find the value of theta in radian, first we know that the total angles of a circle is 360 degree. Since is given in the questions that the angle of the major sector is 290 degree, we can find the theta by subtracting 360 degree with 290 degree. So the theta is equal to 70 degree. Then we convert the angle to radian by multiplying pi over 180 degree. Therefore, the answer is 1.222 radian. For part B, we can find the length of the radius of the circle by using the formula S equal to R theta. Substituting S is equal to 16 centimeter as given in the questions and theta by 1.222 we calculated in part A. So R is equal to 16 over 1.222. So we found R is equal to 13.09 centimeter. Next, let us proceed with the second part of the content standard arc length of a circle. You will learn to determine the perimeter of a segment of a circle and also solve problems involving arc length. Referring to the diagram on the left side, the sine of half a theta is 80 over R. So 80 is R times sine theta over 2. Since the length of the chord AB is twice the length of AD. Thus, the length of chord AB is equal to 2R sine theta over 2. Subsequently, the perimeter of the shaded segment can be calculated by adding the length of arc AB with the length of chord AB. This gives us R theta plus 2R sine theta over 2. Let us try one example together. The diagram shows a sector with center O. If triangle OAB is an equilateral triangle, find A, angle AOB in radians, and parameter B, parameters of the shaded segment. For part A, since triangle AOB is an equilateral triangle, therefore angle AOB is equal to 180 degree divided by 3. That is 60 degree. We convert 60 degree to radian by multiplying 60 degree with pi over 180 degree. This gives us 1 over 3 pi radian or 1.0473 radian. For part B, the perimeter of the shaded segment can be found by adding arc length of AB with chord AB. Arc length of AB is equal to 12 times 1.0473 radian, and the chord AB is equal to 12 cm. By adding both the value together, the perimeter is equal to 24.5676 centimeter, or you can return your answer in 4 significant figures by 24.57 centimeter. That is all for this lesson today. Hope you enjoyed. Thank you.